Okay, our last video is going to be on solubility and also our concentration units. Okay, so let's get started. So our first graph we're looking at here is 4 different substances here, and we're looking at the solubility of these. Now remember, solubility is the ability of something to dissolve, in other words, a solute to dissolve, okay, in the solvent. Okay, let's get started. How many grams of substance D are dissolved in 100 grams of water at 80 degrees Celsius? So go ahead and pause the video and see if you can do it. All right, let's see how you did. So I look at substance D at 80 degrees. So I go over here 80 degrees. I'm going to go up here. Okay, and substance D is this part of the graph here, according to the key. So I go there and I read across. It looks like it's about 240 grams. Now again, you might disagree a little bit with me, but that's okay. All right, let's try the next one. If 100 grams of substance C is dissolved in 100 grams of water at 70 degrees Celsius, is the solution unsaturated, which means it contains less than what's expected, saturated, which means it contains exactly what's expected according to the graph, or supersaturated, which is above what's expected on the graph. Okay, I'll pause the video and try it, and then we'll see how you did. All right, let's see how you did. Substance C is this one here, and we read across there. Okay, and it never ever gets to 100, but let's see, we want at 70 degrees Celsius, so it's about right here. At 70 degrees Celsius, we are barely expecting to have a little bit more than 50, but this question says there's 100 grams in there. So that means we contain more than what's expected from the graph, so that's going to be supersaturated. So I'll circle that one. All right, next one. Which substance do you expect to be a gas? Explain why. All right, I'll let you go ahead and try that. So go ahead and pause the video. Okay, let's see how you did. Okay, if substance that's a gas, and we see the temperature increasing, with temperature increasing, we expect gases to dissolve less. So which graph do we see a downward angle here? So it looks like this one here, the blue one. We see this is angled downwards. So the solubility goes down as temperature increases. It looks like that is substance A. So let's review. What do gases really like? Gases like it when the temp is low. So I'll put an arrow down. And when pressure is high. So I'll put an arrow up for pressure. Okay, so when we keep our soft drinks cold, they stay bubblier longer. And what about that pressure? Well, if you ever release the pressure from a can of pop, you see a whole bunch of bubbles come out. So pressure helps gases stay in solution. And so does lower temperature. Okay, one more question here. How many grams of substance B are dissolved in 300 grams of water at 100 degrees Celsius? Okay, pause video and see if you can try it. Okay, assuming that you did pause the video, let's take a look. So substance B is this one here. So we're looking at 100 degrees. So I'll go up there, and 100 degrees at that location, I read across. And it looks like it could be around 220. And again, you're welcome to disagree with me. But now it's per 300 grams, and our graph is per 100 grams. So we need to times this by 3. And then we get 660 grams of substance B at that temperature. Okay, now let's try our final idea, which is on parts per million. Now remember, a part per million is the same thing as a milligram, okay, per liter. Okay, let's see what we've got there. So we have 19.2 milligrams of iron into 250 milliliters of water in this volumetric flask here. So we're going to fill this up to that line. Shake it all around and dissolve that solution in there. Remember that 250 milliliters is indeed 0.250 liters. So let's calculate our part per million. So part per million is going to be equal 19.2 milligrams, okay, divided by 0.250 liters. And that's going to come out to be 76.8, and we label that ppm Fe plus 3. Okay, so that's how we do that. Okay, try one on your own. we have 45.5 milligrams of calcium into 100 milliliters of water. So this flask, we place it in there and you fill it up with water to the line and shake it all around and dissolve it. Remember that 100 milliliters is 0.1 liters. Okay, one more time, pause the video and see what you got. Okay, so let's see, we want the part per million. See how you did? That's going to equal the 45.5 milligrams. And that's going to be divided by 0.100 liters. And that's going to come out to be 455 parts per million calcium positive 2. Okay, and that's how you do that.